Okay, so in this video we're going to take a look at how a bell works, and it's a nice chance to have a look at some electromagnetism in action. So just to show you what we've got here, so we've got a DC power supply, so this will be supplying a fixed current around our circuit as long as there is a complete circuit. We've got a switch in here just because it'll allow me to turn on the bell on and off, otherwise it would get very annoying. And then we have the actual bell circuit here. So I just want to zoom in a little bit closer and show you the general setup, and then I'll sketch a circuit diagram for it. So essentially what's happening is in the circuit way I've set it up, we can have the current coming in here. We could have it going around here, it really doesn't matter. So what happens is the current comes through here, the current goes up this metal arm that you can see here. Now, and then it gets to the top here. Now, a current will only flow if this metal part here, the arm, is connected to this metal rod in here. So to start with, it is connected, so there will be a current. But if the arm moves to the right, like so, that will actually break this connection and we won't have a current in our circuit. And that becomes important later on. So in terms of how it works when we start it, current comes up here, it goes into this bolt here, and then round the back there is a wire which comes across, and that means connecting into this coil here. So this coil has a current going round it. If there's a current in our circuit, the current then comes around here and also goes around this coil. So we've basically just got two electromagnets here. And then the current comes out of here and back to our power source. So that's the path of our current in our circuit, the path of conventional current, I should say. So let's just quickly sketch a diagram of what that looks like so we can clarify that. Okay, so I'll try and draw it in the same orientation so it makes a little bit of sense. So we said we've got current coming into the left-hand side, so our current comes around here. We've got a switch, which is going to allow me to turn the circuit on and off. That is then coming up here. So I'm just going to represent all of the components as resistors, because they kind of are. So we've got, it goes through the arm first of all. Then it goes across to, let's call it the nail. Then it goes through our first coil. That coil has a soft iron core, so let's draw a line on that to show there's a soft iron core. That then goes through another coil, again with a soft iron core to make it stronger. And then that would come back around to our battery. Now, we zoom in a little bit closer so we can take a look at that. So what is going to happen is sometimes there is going to be a gap in here, or sometimes there's going to be not a gap in here. We'll talk about why that is in a second. So sometimes there will be a current and sometimes there won't, and that's going to be critical there. So just to clarify what I've drawn on the diagram, this part here is what I'm referring to as the arm. This part up here on the top left is what I'm referring to as the nail there. Okay, so let's actually turn our circuit on and actually see what happens. So if I push my switch, so I'm going to close the switch, and you can hear, if we listen closely, you can hear the bell ringing. But if you listen really closely, you will hear it's basically oscillating. So sometimes it's ringing and sometimes it's not. Because what's happening is the hammer is repeatedly striking the bell at the top. So what I want to do is zoom in and we'll take a closer look. So if we go right in here, I said these two are electromagnets. So what's happening is these, when they're turned on, attract the arm over to the right hand side. And what that does is it breaks this contact in here. So the effect of that is it breaks the circuit and turns the electromagnets off. So the arm springs back. So there's a spring on it to make the arm come back to the left. So when the electromagnets turn on, it drags this arm over to the right-hand side and it strikes the bell. But then that breaks the circuit, so then the arm goes back. And so what can happen when I close the switch is that process repeating over and over and over again. So if you listen closely, you can hear the bell being repeatedly struck as the electromagnets are turning off and on and off and on. And I'll see if I can do this. If we zoom in really close in here, you can even see the sparks jumping as this gap opens and closes. So let's try and see that. I don't think those are just showing up too well on the video, but the sparks are in here between the end of the nail and the side of the arm in here. So it's just a nice little demonstration of how we can put electromagnets to use in something every day that you get inside school. Just the final thing, looking at you, so you see there's a soft iron bar going through the middle of them. So this is something we see a lot with electromagnets, because a coil by itself, although it's an electromagnet, isn't particularly strong. By putting a soft magnetic material like iron in the middle of it, we can multiply its strength by factors of thousands. So adding a ferromagnetic or a soft magnetic material into the middle of a magnet can really amplify its strength. And that's what we need for this kind of application, because we're trying to move a reasonably sizable bar left and right. So we need a fairly strong electromagnet in here. But that is our DC bell circuit.